Rates. A rate is a ratio of two quantities measured in different units. A unit denotes an individual item or a single entity. It represents a unique, distinct object from which measurements are derived. Here are some examples of rates. 4 participants to 2 teams, 5 gallons for 3 rooms, 8 burgers to 2 tomatoes. A unit rate is a rate with a denominator of 1. It is often expressed with the word per, which means for each. Here are some examples. 34 kilometers per liter, 2 cookies per person, and 62 words per minute. Click here for a video about Rady the Math Cat. 6 friends have pizza together. The bill is $63. What is the cost per person? Hint: since the question asks for cost per person, the cost should be first or in the numerator. Alright, so here is the rate, $63 for 6 people. Since unit rates always have a denominator of 1, we're going to go ahead and divide both top and bottom by 6 in order to make the denominator 1. When we divide 63 by 6, we get $10.50. When we divide 6 people by 6, we get 1 person. So therefore, the cost is $10.50 per person. The population density of a geographical region is the ratio of its population to its land area. The population is the number of individuals. The population can consist of people, plants, trees, insects, animals, etc. Any unit of area can be used, including square miles, square kilometers, square meters, etc. For instance, we can calculate the population density for humans in Eswatini by following these steps. Find the human population of Eswatini, which is 1,242,822 people. Find the area of Eswatini, which is 17,363 square kilometers, and then divide the human population by the area. So the population density is 71.6 people per square kilometer. Find and compare the population densities for humans and zebras in Eswatini, given that the human population of Eswatini is 1,242,822. The zebra population of Eswatini is 17,190, and the geographical area of Eswatini is 17,363 square kilometers. To find the human population density, we take the human population and divide it by the area, giving us 71.6 people per square kilometer. To find the zebra population density, we take the number of zebras and divide it by the area, giving us 0.99 zebras per square kilometer. To compare the human to zebra population densities, we divide them. So it was 71.6 people per square kilometer divided by 0.99 zebras per square kilometer. These square kilometers cancel, leaving us units of people per zebras. So 71.6 divided by 0.99 gives us 72.3 people per zebras. The population density of humans in Eswatini is about 72 times greater than the population density of zebras. Unit rates are used to make comparisons. For example, Sebastian and Alexandra both worked during the summer. Sebastian worked 26 hours one week and earned $188.50, while Alexandra worked 19 hours and earned $128.25. How do their rates of pay compare? Okay, so we need to figure out Sebastian's pay per hour. So since we have 26 hours in the denominator, we are going to divide top and bottom by 26 so that the denominator becomes 1 hour. 188.5 divided by 26 is $7.25 per hour. We're going to do the same thing over here. Since her rate was given per 19 hours, we're going to divide top and bottom by 19 so that the denominator is also 1 hour. Therefore, the numerator becomes $6.75 per hour. Sebastian clearly earned more, but by what factor? All right, so we are going to divide Sebastian's rate by Alexandra's rate. 7.25 per hour over 6.75 per hour. The hours cancel, giving us 1.074. Therefore, Sebastian's rate is 1.074 times greater than Alexandra's. Or you could think of this as 7.4% more. Jim traveled 480 kilometers and used 18 liters of gas, while Tara traveled 640 kilometers on 16 liters of gas. How do their kilometers per liter compare? We need to turn this ratio into per liters, which means making the denominator 1 liter. To do so, we need to divide by 18. So 18 divided by 18 will give us that 1 liter. But whatever we do to the bottom of the fraction, we have to do to the top. So 480 divided by 18 is 26.7. Therefore, Jim goes 26.7 kilometers per liter. For Tara's ratio, we need to divide top and bottom by 16. So we end up getting 40 kilometers per liter. Now let's compare their kilometer per liter ratios. So 40 kilometers per liter divided by 26.7 kilometers per liter. Well, all of the units cancel, kilometers with kilometers, liters with liters, giving us a ratio of 1.5. Therefore, Tara's car goes 50% farther than Jim's on a liter of gas.